Ever wondered how astronomers first discovered that our universe is expanding? Or how they can tell how far away stars and galaxies are from us? Well, they have the help of a major ally, a phenomenon called redshift. Redshift works similarly to something you might be quite familiar with here on Earth, a phenomenon called the Doppler Effect. Ever notice how the sound of the sirens of ambulances and fire trucks changes as they move? When the ambulance is rushing toward you, each sound wave is emitted closer to you than the wave that was emitted just before, making the frequency higher. Once the ambulance starts moving away, the process is inverted and the frequency drops. Humans hear changes in the frequency of sound waves as changes in pitch. That's why, from your perspective, the siren's sound changes. Light, just like sound, travels in the form of waves. But in the case of light, changes in frequency are perceived as changes in color. The principle is the same. Light waves shift toward the shorter, bluer part of the electromagnetic spectrum as objects in space move closer to us. If the object is moving away from us, the light shifts toward the longer wavelength or redder part of the spectrum, hence the term redshift. But there's more to it than that. The universe is expanding, and most of the galaxies in it are moving away from us, and so their light is shifted toward the redder side of the spectrum. The further away the object, the more significant the shift, which means that astronomers can use redshift to estimate how far from Earth these distant galaxies are. This is why ALMA is so essential. As the universe expands and the light of the most distant objects gets hugely redshifted, the wavelength of their light also shifts out of the visible part of the spectrum toward radio waves, becoming invisible to optical telescopes but visible to ALMA. This allows astronomers to discover new pieces of the puzzle of our cosmic origins.